If you own Garmin's Catalyst and are interested in something to supplement the information it provides, I made an application that will be of interest to you. I own a Catalyst myself and I appreciate the data acquisition it provides, but the data analysis component of Garmin's product felt severely lacking for what I was looking for. The suggestions it would give were mainly about braking a few feet later, a line I took is a few feet longer, or apex speeds being a few miles per hour off from my optimal lap. I was more interested in understanding how my actions affects my car. The G-force data tells you this, but Garmin's presentation here was lacking. I wanted to see how both lateral and horizontal forces relate to each other over the course of time. So I made an app out of this idea and called it ApexSense, which visualizes the G-forces as recorded by Garmin's Catalyst, but in 3 dimensions. ApexSense is free to use, and all it requires from you is to supply your Catalyst-generated video with the Garmin overlay, and the app analyzes the G-force meter and generates a 3-dimensional plot of the G-forces for your analysis. You can find a link to my GitHub with instructions on how to download and use it in the video description, but I'd like to briefly speak on the purpose of this tool and encourage you to give it a try if you own a Catalyst. The basic idea behind high-performance driving on road course racetracks is to operate your vehicle at its physical limits all the time. As a driver, you are given 3 ways to achieve this. You have a steering wheel, a brake pedal, and a throttle pedal. These 3 inputs are reflected in G-force graphs. Lateral G-forces correspond with steering inputs, and horizontal G-forces correspond with accelerating or decelerating inputs. Driving at the limit requires the lateral and horizontal forces to be in perfect balance. If you step over that limit, you'll experience tire slip, which leads to potentially undesirable vehicle behaviors such as understeer or oversteer. By analyzing the G-force graphs, you can deduce how well you are balancing a car while operating at the limit. For instance, if the G-force plot under braking shows a line with jagged or lumpy characteristics, this suggests you're not applying consistent pressure to the brake pedal, meaning you are not achieving threshold braking. Or if you're driving through a turn at the limit and the G-force plot shows deviations throughout the corner, this suggests you're not consistently cornering at the limit of grip, you are possibly stepping over the limit where corrections need to be made to keep your vehicle under control. The difficulty I have with looking at the G-force graphs, as seen in Garmin's Catalyst app, are that they exist in 2 dimensions and they separate out lateral and horizontal G-forces into individual graphs. Or with the G-force meter as seen in the Catalyst videos, this does show both lateral and horizontal forces together, but you miss prior and future context. For instance, I cannot reliably recall how the G-meter looked throughout the entirety of a particular corner. For typical graphs, the correlation of G-force data for trail braking or getting back on the throttle after trail braking are not easily visible when the data is separated. You are applying a lateral force, a steering input, in conjunction with the horizontal force, the braking or accelerating inputs, simultaneously in these instances. So why separate out this relationship? By combining the G-force plots in 3 dimensions, you can see how the combined effects of your inputs is influencing the line you are taking. By viewing the G-forces in 3 dimensions, you see your driving line not based on your position on track, but how your car actually moves through the track. The visualization of this data proved invaluable for myself in understanding how my actions affects my car. If this sounds interesting to you, give ApexSense a try and feel free to leave a comment if you have any feedback you'd like to share.